So welcome. Boy, how far back can you get? Can you move up, Joe, please?
I can't sit still, so I can sit in the back so I can move around.
No, so you want to, you're sitting back there so you,
I want to sit right in the front.
you're sitting back there so you can make a quick escape.
No, I'm here for assessment. I'm with Dave. I can't leave until he says leave.
Okay. For one request, make sure your cell phones are on vibrate, that they don't ring and disrupt us. Okay. So my name's Dick KornBluth. I was a home performance contractor and installation contractor for a long time. Retired about 10 years ago and did some consulting work, and now I'm just having fun. So doing stuff like this. So we're going to talk about, this is not your typical stand up and talk for an hour. This is going to be hands-on. That's why you have those sheets of paper. So what this session is not about, I'm not going to talk about a quality management system, although that's important. You should all have one and live by it. I'm not going to talk about corporate culture, although that's important. You know, corporate culture is the sea in which your employees swim, and the better the quality of the water, the better the swimming is. So I'm not going to talk about that either, and I'm not going to talk about solutions to any problems, because what this is not about solutions. It's about finding what the causes are for the problems. Because if you make the wrong guess about the cause, then you will not get to the solution, and the problems will keep occurring over and over again. So it's about learning the difference in your business between processes that operate your business. So there are processes that work okay, but they can be improved. Okay, they're not broken, but they can be made better, and that increases efficiency, and that makes you more money. And then there are processes that are not working, that are not operating, and in fact, they're broken. And when they're broken, they cost you money because you have to spend money to fix them. So we'll be learning about tools and techniques for solving the problems, these profit-killing problems that might be an issue in your business. And then you're going to practice some of these here, and you're going to take away some of these tools that you can then incorporate into your own business and use them to solve the problems that your business encounters. So how can any business increase their profit or productivity? You know, you can increase, this is classic, you can do more business, you can increase sales, you can increase your prices, and you can reduce costs. I'm not going to talk about the pluses and minuses of these things, except increasing sales, means additional costs to do that. Increasing your prices can put you at risk of competition. The third way is to reduce your costs. So you can make more money in your business if you reduce your costs and keep your revenue the same and keep your prices the same. So we're going to talk about that. So let's talk about reducing costs. Well, we need some terminology to have this conversation. So I'm going to define a term, and the term is process. And it's simply defined as a set of steps that are followed to achieve a certain goal or outcome. And those steps have to be in a certain order, so they're logically connected. So what is included in a process? One is a clear goal or objective. So a process always points to some end that is a goal or objective of the process. And the other part that's included are defined steps or actions to achieve that goal. Okay? So if you have a clear goal in mind, and you actually have the steps that are necessary to get from here to there, then you have defined the process of getting from here to there. So there's two ways to look at any process. One is design. So that's the way you do things. It's basically the steps that make up the way you do things. And if you understand those steps individually, then you understand the process. But the second way to look at a process is the actual doing of it. So when you do the process, those are the actions that correspond to the design, to the steps in the process. So that refers to operations. So you have a design part in your process, and you have an operations part in your process. So when you put the process into effect in the real world, what happens? Does it work? Does it not work? Does it break down? Are there issues with it? So we look at both parts of these as parts of the concept of a process. And how do you describe a process? What's the best way for you to understand the processes that go on in your business? And it turns out that the best tool for that is really a simple tool called a flow chart. And a flow chart is just a diagram. And it's a diagram that uses graphic symbols that depict the nature and flow of steps in a process. So you have step A going to step B, going to step C, going to step D. Okay? And you have a starting point in that, and you have an ending point. So what are the benefits of flow charts? Well, one benefit is it helps you understand how your organization works. Do you know how your organization works? If you can describe it to someone, you say, well, this is how we do stuff. We do this, and then we do that, and then we do that. If we want to get from here to there, here's what we do. And it's a way to graphically illustrate that. And what that does, it helps you understand how your organization works, because you break things down into pieces that you can easily comprehend. It's also really helpful for defining problem areas. For example, Alexander Zverev, who was the #2 tennis player in the world, he was having problems with his serve. And so he went to his coach because he wasn't getting enough velocity on his serve. And so what they did is they filmed his serve, because you think about a tennis player, they throw the ball in the air, they reach back, they hit it. You think it's like a continual thing that happens. It's just like one flow. But it turns out that if you break it down into specific steps, you could then look at each step in that process and see, is there something that's not working? And it turned out that the reason, and they did that, they filmed him in slow motion, they broke down each movement that he took in making that serve into separate pieces, and lo and behold, what they discovered was that he was throwing the ball too high. And so he spent time waiting for the ball to come back down to where his racket can reach it. And by that time, he had lost all momentum in his body, and he had lost, 10 miles an hour or whatever on his serve. But it was the last step, it was the last thing he did before he swung the racket that they figured out was the problem. But if they had just looked at the whole thing as a continuous motion, they would not have understood that. So they got him to lower, to throw the ball up less high, so that when he reached back, he had more force in his racket, and he got another 10 miles an hour or whatever on his serve. So it helps you to find problem areas. It helps you if you're going to design improvements in your process. So if you find a part of your business where the process seems to be slow or not working efficiently, by isolating that step, you can then work on that step and make that step more efficient. It's also a great tool for training. So how do you do a flow chart? It's basically simple. You have symbols that correspond to operations. So you have a step in the process is a rectangle. If there's a decision that has to be made, then that decision is a diamond shape. And you have arrows that connect the parts of the process together, going from A to B. And also you have a beginning and end step, which is simply a box with round corners. And that indicates the start of the process and the end. So here's a really simple one that I made up. You want to draft a procedure. So what you do is you start, you draft the procedure, you type the procedure, you distribute the procedure. Really simple. It's just straightforward. A, B, C, and you're done. But let's say it's not that simple. Let's say you draft the procedure, and then it turns out that that you may or may not have to get approval. So you put a decision tree in there, you put a decision symbol, and if the question is needs approval and the answer is yes, then you go off to the side, you get approval, and then you go back into this flow and you type the procedure and distribute it. But let's say that in this procedure, you don't need anybody's approval. If the answer to need approval is no, then you just continue down the track. Is that pretty clear to everybody as an understanding of the use of the decision process, the decision symbol? It simply means at any point in a process, there may be a decision to be made. And the decision can be, do I need something done, or do I have to go backward to get approval and then come forward again, or can I just progress down the line? But decisions can move forward or backwards. If you turn out the light, this will get easier to see. Just right that side. Is that better? Sure. Okay. So I'm just going to read it because it's hard to see on the screen. So you're drafting a resolution, right? Draft a resolution. The first decision is the rough draft done? The rough draft done? Oh, if it's not done, then you have to go edit the rough draft. And then you go into the next step, which is to type the rough draft. And then you say, are corrections needed? And if the answer is yes, over here, you make the corrections, you go back into the previous step, and then you go down the tree again, and it says, are corrections needed? Now that you've made those corrections, the answer is no. Then you type the procedure, and then you produce the draft. So you can have a decision that says at the top, is the rough draft done? If the answer is yes, you continue, then you type it, and then you have to go through this decision tree, or corrections needed. But if you type the rough draft and it's not done, you then have to go back into the rough draft and edit it to move forward. So decisions are useful in several different ways. And in any business, I'm sure in your business, you encounter situations where questions arise. Is it ready for this? Are we ready to move on? Et cetera, et cetera. How did that happen? Okay. So you can have feedback loops, or you can have, this kind of situation where you go back and edit it and go back down again. So what are the keys to using a flow chart? You have to observe what you're doing. You have to start with clear, well-defined starting and ending points. You record the steps, you arrange them in sequence, and you draw the flow chart. You have a blank sheet of paper. Now we can turn the light on. I'm sorry, can you turn the light back on? So this is for each person individually. I want you to think about something that you do, preferably every day. It can be personal or related to work. We're going to do this like 4 or 5 minutes. I want you to break it down into steps. The steps have to be in sequence. And then you record them, and your flow chart has to have at least 3 steps, minimum of 3 steps. And I'm going to time it. We're going to do 5 minutes. Don't have to put a box around it. You just have to list them. I really, really appreciate the water, Damien, but there's no glasses.
That wasn't me.
Thanks.
I like to provide glasses.
Oh, there's glass in the back. Thank you. Oh, great. Thanks. Thank you. Thanks. How many people are still working on it? Okay, we're going to stop. So we can so I want one person to share. At least one person. Just share what you did. Share your flow chart. Okay, Joe.
Woke up, then I had a decision matrix. There was a dog awake, dog's awake, walk the dog, make coffee, drink coffee, drive to work.
That works. Anyone else?
I apparently have the same routine.
Okay.
Take dog for a walk, ask dog. Usually says yes. Get harness, put leash on, get poop bag, get jacket.
Yeah.
Go
So,
outside.
so I did this to a bunch of New Hampshire weatherization field guys. And I asked for a volunteer, and a guy stood up and said, I woke up, took a shit, and went to work. I said, thank you. I said, thank you. Okay, everybody got the idea? Are there any quick questions about doing this? It would be very interesting if there's something in your own life that you're maybe not working, and you can take this exercise and do it. It's the easiest way to do it is personally, but you need to apply it in your business, and you'll find out very interesting things about how your business works or doesn't work when you do this. So that's the first one. So Joe actually did this step, which is to add a decision. So, you can have the yes and no on this side or that side, depending on the kind of questions you're asked. So if you ask, is it done? If it's no, you go to another operation. The other way is if you say, is it needed? And the answer is yes, then you have to go do X and go back around. So decisions can go in different directions. So we're going to skip this because Joe basically had a decision in his sharing. So how do you apply this to your business? Well, you analyze the overview of your business and you list the processes at a really high level. So you might have sales, marketing, production, billing, and then you break each process in your business down into the steps using a flow chart, and then start looking at those steps and looking at them and examining them and saying, are they working as well as they could? Or are there things that we can do to make those steps more efficient? So this is in the design area. Does each step in the design move you forward toward getting your goal? And if the answer in the step is no, then you got to redesign the process. And if the answer is yes, you got to look at the step and see if it could be made more efficient. This is where brainstorming is useful. I'm a huge fan of getting as many people in a room as possible and actually putting all those brains together, because you never know where good decisions and good suggestions come from. So not all processes work. Does this design make sense? I wake up, I shower and shave, I get dressed, I eat breakfast, I go to work. Does that work? Does that make sense? As a process, does that make sense? How about this one? I wake up, I get dressed, I shower and shave, I eat breakfast, I go to work. No, that process does not make sense. So the design itself has to actually move everything forward toward the goal. And if it doesn't, or if it causes problems in the process, you need to look at that.
What if that was the way you clean your clothes?
Then it works. If the goal is getting your clothes clean, then that process works. Except of course you left out the step about drying, right? So I'm going to give you a couple of examples of how to make designs work better, okay? So here's an example. This came from a real life case study. So there was an office. There were 10 people in the office, and there was one big printer in the office. And so everyone who had to print had to wait their time, at a wait time for them to get to the printer, because they had to get in line to get to the printer to get their printing job done. So that delay in printing caused a significant increase in the operating cost of that office. Nothing was broken. Everybody, the printer worked. Everybody got in line and waited and got their printing job done, except they hired someone to look at the efficiency of that operation, and that person said, that's not working. The design is flawed. So what they came to is that instead of one printer for the office, standing in line and waiting, they ended up by putting a small printer on every desk. So the whole waiting issue went away. Now, there was a capital investment in doing that, but the time savings that resulted from that literally paid for the capital investment in installing those little printers at each desk, and I think like less than 2 years, including all the maintenance costs and IT costs for keeping them going. So the increased efficiency in the office operations paid for the capital expense. Was the design functional, the original design? Yeah, it was functional. It wasn't broken, it just wasn't efficient. So this is one I completely made up, but it illustrates the point. So let's say every day I go to work and I start here and then I go there. And this is my route, and I take this route, and I got 3 traffic lights. And it turns out that I start thinking about that, and I figure, is there a faster way to get to work? So I redesign my travel. Instead of going this way, I go this way, and there's only 1 traffic light. And it turns out that I save about 5 minutes each way every day, going to work and coming back from work. So what does that end up? Well, before the trip might have averaged 30 minutes. Then after, the trip averaged 25 minutes. So I've now saved 10 minutes a day. So I save 5 minutes per trip, or 10 minutes a day. That's 50 minutes a week. That's 2,450 minutes a year based on 49 weeks, because I have a week of holidays and 2 weeks of vacation, which it translates to 40 hours a year, which means I literally, by saving that 10 minutes a day, I add a full functional week of productive time to my work every year. So that's a simple design change in a process that wasn't broken. That gives you an idea of how that works. Now let's turn to process execution. That's operational. Breakdowns, that's when you have breakdowns. And the key to prevent future breakdowns is to figure out and understand what the root causes of those breakdowns are. In most cases, the root causes in a breakdown of an operation are going to be found in the processes that are not working. The natural instinct, if you're the owner of a business, if something goes wrong, and we're going to talk about this briefly, is to look for the person responsible for the screw up and blame that person. And I will tell you, standing here, that in most cases, ultimately the problem is going to be a process that's not working. So how do we uncover those root causes of those processes? So here's an example of a process execution problem. In this case, it's not anybody's fault, it's the environment, right? Okay, what about this one? That's another process breakdown problem. Okay? So we use tools to figure that out. So by understanding and distinguishing the steps in a process, it makes it really easier to identify the steps where the operation breaks down and the steps where the root cause of the problem is. And by the way, where the breakdown occurs is often not where the root cause of the problem is. And that's the key to understanding where we're going here. So breakdown are almost always a process execution problem. So what do you do when there's a process execution problem? I want everyone in this room who has never had a problem occur during a job to raise their hand. Okay, so we understand what we're talking about, right? So you have a couple of options here. You can ignore the problem. Of course, then it happens again for sure. You can just say, just go send a crew out and just fix it, right? That guarantees that it'll happen again also. You can find someone to blame. That's the easiest one to do, but that never gets to the root cause, almost never. I mean, I'm not saying that there aren't toxic employees, but I'm saying in most cases, it's not because some employee had bad intentions. It's because something went wrong, and blaming the person is not going to solve that problem. The ultimate answer is to figure out what is the ultimate cause of that problem and change the process so that the problem doesn't occur. So we're going to, so what about blame? Blame is a bad way to deal with problems because it creates toxicity in your company. And what happens is it creates fear, hostility, discouragement. People will be afraid of coming forward and identifying, working problems because they're afraid of retribution. It affects morale and productivity, and it ends up with a cover my ass culture in the business because the fear is that you're going to get, fired or punished or whatever. None of that helps your business. None of it. So what's left then is to figure out the root cause of the business. And how do you do that? You do that through the use of tools. Now, here's a sidebar. This is about language. This is about language in your business. You can say something's wrong. Problem with the word wrong is that wrong implies blame, narrows the options for getting to the root cause because it actually makes somebody bad. Or you can say something's not working. You take the moral judgment out of it, and that opens up the door to having conversations about what went wrong. If you say something's wrong, then somebody did something wrong. And then it makes it hard to get to the real cause of the problem. If you say, hey guys, something's not working, let's figure out what's not working, it means that people are then enrolled in the process of figuring the problem out. The other thing is fault and responsibility. Fault is a value judgment. And once again, it's a negative value judgment. It assigns blame, but saying I'm responsible for something, there's no morality there. I accept responsibility for something, means I own it. It doesn't necessarily mean I'm a bad person, but it does mean I own whatever it is that I'm doing and what's happening. Okay. So we're going to talk about fishbone analysis. So you have a couple of sheets of paper, and we're going to use those, and we're going to do some group stuff. So it's a brainstorming tool. And it's used to uncover the root cause of problems. And it's useful with another tool, which we're going to get to, called 5 Whys. Okay, so here's a fishbone diagram. And if you look at it, it's called fishbone because it looks like the skeleton of a fish. And how it works is you have a problem statement, and that's sort of the backbone of the fishbone chart or diagram. And then you have ribs coming off of it. And each rib is going to have a title, which is essentially one possible category of description for the problem. So you've got one that's labeled. So you're going across the top. And by the way, I chose these 6. You can have your own. You can make your own categories. But I thought these categories were really appropriate to the weatherization, which is my business, insulation. So there are methods, there are materials, there are measurements, there are environment, which is the flat tire, right? The car and the flat tire. There's people, which means that the problem is with people. And then there's machinery, problems with the machinery. And so each of these ribs has a different category of possible answers to the problem, or what is the ultimate cause of the problem. Okay, so how it works is, for each category, you brainstorm all the possible causes of the problem, and then you assign them to the appropriate categories. Don't attempt to get the answer. This is brainstorming. This is, what are all the possible ways that that problem could be caused under each, or not, and maybe not all the categories are appropriate in any given time, but under each of those categories, you brainstorm what are the possible ways that those categories can relate to the cause of the problem. And you just brainstorm it. Some categories might have several causes, and some very few or even none. There are no requirements. Then you have to, this is all step one. Then the next step is to look at the ones that are most likely going to be the answer or the causes of the problem. And then you apply another tool called 5 Whys to actually drill down and get to the root cause. So what about the categories? As I said, they cover all the possible ways the breakdown could occur. And that list can change depending on the type of breakdown. I mean, if you have a sales problem, you're going to have a different set of categories than if you're having a production problem. But the technology is exactly the same. You're basically brainstorming the possible causes of the problem. So how to create it: straight line, problem statement, diagonal lines at the end of each rib. So here's a fishbone. I would like you guys to work in groups of at least 3, maybe 4. So turn your chairs around if you can. Figure out a way in this room for you to collaborate together. So 3 or 4, no less than 3. Figure it out. Just figure out and get together. By the way, so you're going to create I've created a problem for you. So I'm saving you the trouble of having to create a problem because I made one up. Here it is. It's a sidewall dense packed cellulose project. At the end of the project, you discover, either from counting bags or from taking a core sample, that the cellulose in the wall did not achieve dense packed density, which is 3.5 pounds per cubic foot. That's the problem. So I want you to brainstorm using the categories that I created on the sheet with the categories. And you got 5 minutes. So who's going to chair this group?
This guy right here. He's pretty good at it.
Okay, so you have the sheet of paper with the categories listed on them, right? Look at one of those sheets.
I think I messed up.
I did that too.
I got 2 of those and 2 of
Here,
those.
I think I have.
Similar.
Maybe you have the
That's
other
not
one.
it.
No, that's the one I
Well, I
got.
got them all.
Keep going. Keep going.
I grabbed everything you had back there.
Keep going.
I got every. We don't have it either. Yes.
Okay. Maybe I didn't hand out enough. Here, make your
It
own.
wasn't back there, right?
No. Here, draw it. Here, you can make your own. You got it. You had one.
Yeah, but I was just the gun so quick.
Make one up. Here. You got a sheet of paper. Here, make one up. On here.
Thank you.
Patrick, you love it? Yep, you're good.
All right, so materials.
Look at this one. I could have sworn. So you got methods, materials. So I handed these out, and I didn't have enough, I guess, right?
I guess not.
Right.
Okay.
Oh, that's why.
So you got methods, materials, measurement, environment, people, and machine are the categories. So just figure out, look at each one of those. So what if there's a method that's a problem, what's the method? If there is materials that's a problem, what's the materials? If there's
Not be enough bags.
what?
Not be enough bags. Is that what you mean?
I-
I know. I was just brainstorming.
Brainstorm. So if it's machine a problem, if it's people, even if it's the environment.
The machine, too much material,
Well,
not enough air.
that's right.
So you don't get 3.5 per.
Yeah, but still, at that point, you would think that the guy knows.
Okay. So you have categories: methods, materials. Oh, that's fine.
Yeah,
Doesn't matter what it looks
yeah,
like.
we're using your, and it would just
Yeah.
quickly just.
Third party and
Yeah, and I put there like also.
So you got the categories: methods, materials,
Yep.
measurement, people, machine, environment.
Yes.
Oh man, like the
Yeah.
emails themselves sent around for like,
How you doing?
we're not
Doing
doing
great.
your problem.
Yeah, we're not building
We're not
science people.
contractors.
So you're what?
We're with the
Energy hub.
That's fine.
Yeah, we're doing.
In my mind, it doesn't
You don't
matter.
have any problems with the hub, right?
Oh no, never.
Oh yeah.
You just adapt the technique to
Smooth
your
sailing.
own.
Yeah.
The only thing is the categories change. That's all.
Right. Exactly.
Environment really could be cross bracing, could be hidden cavities that you know from. We recently went to a home and used a lot of material.
Dick's got us working.
Well, I
Ray
warned.
wasn't ready to work today.
I warned you. This was gonna be hands on.
Yeah, you warned us we were already in
Huh?
We're just taking a peek at what's here.
Yeah. So how you guys doing? You got stuff, right?
Yeah, we got a pretty good one coming up with
Should have worked with them.
here there.
No, I'm kidding. I'm having a hard time.
I've been out on these problems.
You've been what?
I've been on jobs with these problems.
I'm sure. I'll bet you have.
I think that we're going in to see if there is like a section wall. Training, you wouldn't know, like the base, cover the window, for instance. Right. Someone's gonna have to.
Personal, I got spill on.
Is that what was that one with Jackson
Yeah. And a wall down.
That was what I
That's what I mean.
The IRK was with the blower door test to be used for.
Yeah.
There's a lot of. No, it helps.
Or pushing the really fast and trying to get it from.
I was using it real. Well, it was a really expensive player for like, I don't know, a long time ago.
Sure, yeah, it really is.
No, it was colored, but it was like one of the big ones. Yeah. Yeah, this is like.
I'm more struck that you would do a green light.
Okay, okay, can we, let's stop for a minute, okay? Okay, thank you. The chances are that you could spend another 15 minutes doing this, but you get the idea. And what I want is for someone, I want this is free for all here. You all working on the same problem. I think it would be really useful if we do some sharing. So, which group wants to start first? Okay, Joe. Just list the category and list what you came up with.
So materials, bag density, bag size.
Okay, so, okay.
Methods was training. Personnel was training and spilling on the ground. Environment was moisture and the weather. Equipment was the blower, the mixer, lost. Measurements were depth and area.
So give me so when you say issues with measurements with depth and area, what does that mean? I mean, give me that in like real terms. Why would that affect the density in the wall?
Well, because if you have if it's 100 square feet or it's 200 square feet, and you have 10 bags going to it, you're going to have a different density on each one of the walls.
Okay, so the question then, so that's a measurement issue.
Yeah, that's what it was under, is depth and area.
Okay, so area meaning the surface area of the wall. So there's a miscalculation. In other words, what I'm asking is, if you have a technician installing the cellulose and you didn't bring enough bags because someone miscalculated the area of the wall, then you would run out of walls to insulate, but every wall that you insulated should have dense packed cellulose. You just don't have enough to do the whole house. So what would cause a problem if the density in the wall was not 3.5 pounds per cubic foot? Could be machine setting, right? So the machine, so it could be the machine setting. And if it's the machine setting, then what's the root, we're going to talk about the root cause and getting 5 whys to figure out if it turns out that the machine setting is the problem, which might get uncovered by doing this, because you're looking at all the possible ways that this could happen. That's one of the ways this could happen if the machine setting, if was not set right for dense pack. That's one possibility. Moisture is another, right? Moisture, if the cellulose is wet and it's heavy and wet going through the machine. So all of those things is what I'm saying to you is, all you're doing here is saying, what are the possible things that could possibly cause this problem? Then you can go back and look at the cellulose in the bags. You could look at the machine setting and ask, what was the machine setting? Because I picked an issue where there's a whole lot of different ways that could cause a problem. So then the question becomes, so are there any other answers anyone else come up with, John?
So we got under methods, we got not properly sticking the hose up high enough and doing a proper density
Right.
check on the wall.
Right.
And, things like cross bracing or horizontal bracing.
Right.
Where you don't get the cavity above it. So
Right.
you're not checking,
Right. Yep.
verifying that you have the full wall.
Right. So there's lots of things that can go wrong. I picked one because I was an insulation contractor for 30 years. So I've encountered every conceivable screw up that could happen in a house. So I picked one that I thought would be complicated. So what's the next step after you've gone through the exercise and you've narrowed it down? You've narrowed it down to a few possibilities. This is a process of starting with everything and then getting down to a few possibilities of why the problem occurred. Okay. You get to the last one. And what's interesting about this is that it's unbelievably simple. And how it works is, it's a technique for drilling down into a problem to uncover its root causes. And how it works is, there's a problem and you say why. You ask why. And you get an answer and then you ask why. And you keep asking why until you get down to the root cause. It sounds like almost childish, right? Except my wife was a documentation clerk at Carrier and she worked in a department filled with engineers. And then they did this. Engineers did exactly what I'm talking about to figure out what went wrong when things went wrong, is they used 5 whys. It's called 5 whys, but there's no such fixed number. It's possible you can get there with 3, and it's possible it could take 10. So you use the fishbone technique to narrow the choices, and then you go to 5 whys to figure out the root cause. Now, I am going to play something, and I really agonized over playing this. Because, first of all, it's Louis C.K. who's an asshole, okay? And second of all, there's some bad language in here. But in my life, I have never heard the 5 whys technique used so profoundly as in this video. So I'm going to play it. Oh, it's the volume is too low. In fact, it's not volume at all. How do you turn it up? This is their speakers, and I have no idea.
The volume coming out of the projector here.
Okay. Can I, give me 1 minute, because I'm going to plug my own speaker in. Sorry. I brought one. Oh, shoot. I gotta find the cord, the cable. They assured me that it would work. And it didn't. Yeah. I need, you know what? I need to do, 5 whys. I need to do 5 whys on the AV people in this building. Okay. This one I know works. Okay. Let's try it now. You can't hear it, right?
Still going through the projector.
No, it shouldn't go through the projector. It should go through here.
Shouldn't.